Okay, yes, Vandana, you are preparing for UPPSC, right?
Yes, sir. Physics.
UPPSC for the post of lecturer, right?
Yes.
And in the domain of physics.
Yes, sir.
Okay. Okay, Vandana, so let's go ahead and first of all, introduce yourself briefly to us.
Okay, sir. Thank you. Good afternoon, sir. As you know, my name is Vandana Tomar, and I belong to Muzaffarnagar district in Uttar Pradesh. And I have done my basic education from here only. Then I did graduation in physics honors from Ramjas College, University of Delhi. Then I did post-graduation in MSc Physics from CCS University, Meerut. And there I was awarded a University Chancellor's Gold Medal Award. So I was motivated enough for my further advanced studies. So I prepared for different examinations such as NET, GATE, CHEST, all these. And fortunately, I was able to crack all those exams. And I got the opportunity for pursuing PhD from IIT BHU Varanasi. And this whole program was fully sponsored by MHRD GATE Fellowship. And recently, I was just awarded this PhD degree in April 2022.
Okay. So you have already completed your this PhD in physics, right?
Yes.
Okay. From IIT BHU.
Yes.
Okay. So what was your research area, Vandana?
So I was associated with solid state physics lab. My thesis title was Investigations on Perovskite Chalcogenide Glass Ceramics for Energy Storage Devices. So basically, it was in the material science domain. So we analyzed different composites of glass and ceramics, and they were fabricated for a device fabrication so that it can have any commercialization use also. So I worked on that domain.
Okay, so see, you have done this PhD, already completed PhD, and you know at this polytechnic level, you basically deal with the very basic physics, isn't it? So don't you think your capability or your that depth of knowledge will be underutilized over here?
Sorry, sir, I will differ from you here because I was from the very start of my journey, this academic journey, I was very passionate about teaching. I have done it at various levels also. So level is not a major concern for me, and it's a good platform to start with so that the skills that I have earned during all this my academic journey and my PhD also, my research, my teaching skills. So I'll be using my all capabilities and capacities in the efficient way from the very start so that students can also get benefited from me, and I'll be using my all experiences at my best of my knowledge.
So mostly it is the applied physics domain, you know. Engineering, it is going to be the applied physics domain. So will you be comfortable with that?
Yes, sir. Actually, I have done BSc in the core BSc Physics honors. So it was an honors degree. So I have dealt with all the domains of physics at my graduation level. And also my MSc specialization was in electronics. So applied part was fully covered in that area. So I am confident enough to take up this position and do justice with this.
So, okay, where else do you think you can contribute? Let's say if given the choice that, okay, you are not appearing for UPPSC lecturer, right? So where would you have just gone and applied your knowledge, or where would you have joined?
Other than that, sir, I have different options such as higher education, the UPHESC, and at various degree college levels, and engineering departments also in applied sciences. I can opt for that also. So various opportunities are there, but right now I'm just having this only opportunity.
Are you looking forward to those opportunities in future?
Right now there is no option for me. This is the
no. I'm saying, are you looking forward to those opportunities in future?
Yes, sir. I was looking for different positions, and this come across first, so I'm having this only.
You didn't answer my question. You didn't answer my question. My question is, will you be looking for those options in future?
Sir, in future, everyone wants a good opportunity, and if I will do good at this platform, and I will be having job satisfaction here, so definitely I will not look for any other opportunity. I'll be satisfied with this position only.
Okay. You have done your this thesis part in your. So what was it? It was related to something kind of composite that you talked about.
So composite for energy storage. Yes, sir.
Composites for energy storage, right?
Yes, sir.
And what kind of composite did you study over there? It was composite of what?
So I dealt with three forms: 0, 0 form and 1, 1 form. 0, 0 form means bulk form. So we did literature for the glass counterpart
No, no.
and the ceramic part.
I'm talking about the material.
The material.
Hmm.
So it was barium strontium titanate and tellurium oxide. So their composite I prepared.
So why you chose those materials only?
Yes, sir. Yes, sir.
Well, why did you chose those
So,
materials only?
before starting the research, we did thorough literature. So based on that survey on 10 review, based on different review articles and 10 years survey, we analyzed that lots of research has been done on the barium titanate based ceramics and also on barium strontium titanate. But it was a novel idea to mix a glass with ceramic. So we did literature in particularly in that domain, and we analyzed bulk form and thin films form are not very well studied, particularly for the BSTPO2
So
composite.
what are their application? Like for example, what are the application of these composites?
So there are different properties of such composites, such as pyroelectric properties, piezoelectric. So for a dielectric capacitor or for having energy storage, we need materials with high dielectric constant and low breakdown strength. So these materials are promising candidates because they were showing these properties very well. So we can design in future a cantilevers or multi-layer cantilevers, which is a good energy storage component of any device. So application part of this lies in the form of capacitors.
So what are the present materials used and how it is basically, how much difference? You must have carried out the comparison, relative comparison, right? With the some kind of benchmark material which is being used currently. So what is the current material which is being used currently?
So we did literature for different composites, and we find out the maximum energy storage was found around 13 joule per meter cube centigrade inverse. But for our system, it was coming around 17. So it was and also it is a lead free, and all those studies were performed using lead based ceramics, and there is a problem with lead. It's a toxic material, so we need to get rid of this toxicity. So we were switching towards the lead free materials. So it is a better advantage that we are getting higher value also for lead free compounds. So that was the advantage and novelty of our work.
So it is not the composite that you just spoke about, it is not being used currently, right?
No, sir. Yes, sir.
So do you see its use in future?
Yes, sir. Actually,
do you see its commercial viability?
Yes, sir. I see it, and my juniors are working on that front. As I have done the theoretical and the initial part, and my supervisor had hand over this work to my juniors, and they will be working on device.
Have you carried out experimental work also?
Yes, sir. Yes, sir. The fabrication part, the characterization part, and the energy storage, all the measurements were done by me, and all the results were analyzed by me, and the report was prepared by me, and the device fabrication, the application part is given to my juniors. So we are working in a group. So I started this work. Now this concluded the part is hand over to my juniors.
Okay, Vanna. So we'll give you the feedback, and then now over to Jyoti ma'am.
So Vandana, you have studied about solid state physics, right? So can you draw BCC structure and tell how many effective number of atoms are there?
Sorry, ma'am, I didn't get the question.
Can you draw the BCC structure and tell me how many number of effective atoms are there?
Okay. So BCC means body centered cubic. So it's a cubic structure in which at the corners we are having 8 atoms, and these corner atoms are shared by other 8 cubes. And in the structure itself, inside the structure, inside the cube, we have one whole atom. So in total, we can say these 8 corner atoms are shared by other 8. So the net effective atoms will be 8 multiplied by 1 by 8 plus one whole atom which is inside the body. So in short, we are having effective number of atoms as 2 in the BCC structure.
Okay. So if we consider a closed packed structure, then can you find the relation between the cube length and atomic radius of BCC?
Yes. So as we see draw body diagonal for this particular structure. So we see body diagonal is nothing but 4R. 4R. It means 4 atoms radius to R. So 4R is this diagonal. When geometrically we will find out the length of this diagonal, it will come out to be as root 3A. So in short, 2R is root 3A by 2. So nearest neighbor distance, that is 2R. It is coming out to be root 3A by 2.
So, okay. So have you prepared anything for demo?
For demo, ma'am, I prepared quantum mechanics topics and of course solid state.
So in quantum mechanics, can you draw infinite well and draw its first and second states?
Yes. One is potential box. So now, first of all, what is this potential box? So first of all, we will try to analyze the significance, physical significance. We will not just start with the very start, what is the energy functions and wave function. First, we will feel this term potential box. So as you know, when electrons revolve around the nucleus, so they are orbiting in the vicinity of the nucleus. It means they are experiencing electrostatic forces. These can be repulsive forces, attractive forces. So those vicinity interactions are termed as potential boxes. Yes, electrons are moving in the potential, in the territory of a potential. So this is the term which is I'll be using here. And 1D means for the simplification or for the very starting point, we have only the movement in the one direction only. Then it will lead us to 2-dimensional and 3-dimensional. So we will start this 1-dimensional. So first of all, we need to define the potential. So I am taking this as a potential box. So definition of this potential will be V is equal to infinite for the boundary points. Like when x is at A and x is at 0, V is infinite. Otherwise, V is 0. It means electron is free inside the box. So any particle, as per se, any particle is free inside this potential box, and when this particle reaches the boundary 0 or A, it experiences the infinite potential. It can be termed as potential barrier. It's a kind of obstacle in the path of particle which is moving or trying to move at the boundary. So this is the definition for this particular potential. X is less than 0 or x is greater than a, it is, and x is between 0 to a, it is 0, and x is around, otherwise it is infinite. So this is the definition. First of all, we define the potential. The next step comes Schrodinger equation. So any system, when we will deal in quantum mechanics, they will be solved using Schrodinger equation that is time independent. That I have discussed already. So I will take time
Just
independent.
draw the wave function. You can draw the first two wave functions, okay?
So sine, after calculating all these terms, we will get a wave function as 2 by a sine n by x by a. So this is going to be wave function for any particle which is confined in this potential box. So based on different values of n, and from 1, 2, 3, we get different wave functions. And if we talk about the energy terms, En is nothing but n square pi square h square divided by 2m a square, where n is the quantum number, h is Planck's constant, m is the mass of particle, and a is the length of this box. So now I can write different energy terms for n is equal to 1, or the energy value for the very first state, even as pi square h square divided by 2m square, and similarly E2 has 4 pi square h square over 2m a square, and so on. So what we see here, when a particle is confined in the box, it is governed with this wave function, which is a plane wave solution. But energy eigenvalues are showing discrete values. So quantum mechanics has introduced here the quantization. So the things we were seeing till now, that energy is spontaneous. But here, when we are dealing with quantum mechanics, it is discreteness of energy levels is coming here. So if I will draw these energy patterns for n is equal to 1, this energy wave function n is equal to 1 is like this, for n is equal to 2 loops, and so on. So these are the waveforms for different n is equal to 1, n is equal to 2, different n values for different energy level functions.
What will happen if we take this length as minus a by 2 to a by 2?
So if you take minus a by 2, a by 2, so also the length is also same here. So energy eigenvalues will not change. Only the wave function form will change.
What will be the wave function for this?
This will this root 2 by a will be root 1 by a.
Okay, fine. Are you aware of thermodynamics also? Have you prepared thermodynamics?
Time.
Have you prepared thermodynamics topics also?
Yes. Yes.
So can you tell me what will be the change in entropy when ice melts into water?
So when ice melts into water, volume decreases. So because volume is decreasing, solid form is changing from liquid state. So entropy will increase, because the entropy is the measurement of disorder. So disorder is increasing, that's why entropy will increase.
Okay, what will happen to this entropy when there is expansion of gas into vacuum?
Water to liquid to gas.
No, this is different. What will happen in the free expansion of gas into vacuum?
In the free expansion of gas, entropy remains constant. It doesn't change.
Are you sure?
Maybe I'm mistaken, but I will do a check on it.
Can you explain any two thermodynamic potentials?
Yes, yes. So there are different physical parameters which govern the whole thermodynamics, such as, first of all, internal energy, F Helmholtz free energy, and the H, enthalpy, G, Gibbs free energy. So these are the thermodynamic potentials. So when we talk about H, it is U plus PV. S is U minus PH, PS, and G is G H. H.
Explain anything. Explain
Forget
anything.
it. Yes, this enthalpy. So enthalpy is nothing but the inherent heat. So like we study in the experiments such as porous plug experiment. So there comes a term called enthalpy, which remains constant. So it is U plus PV. It means when a system is compressed or it is expanded, its internal energy changes. But along with this, there is a change in pressure and volume also. So this U plus PV term is again classified as the H, because just the nomenclature. Like U plus PV term is going to remain constant, so we are giving it a new name like H, which is the Helmholtz free energy.
And what is F?
S is free. This is Helmholtz free energy. This is enthalpy, and this is U minus Ts. Again, the term, whenever we come across this term U minus Ts, so it is termed as F. So based on different pressure and the volume entropy changes, this F can be calculated for any thermodynamic system.
Where we can use this?
This S term. So this like phase transition processes when we study the solid to liquid, liquid to gas. So these in any kind of phase transitions will be governed with these potentials.
Okay. One last question. Can you derive real gas equation from ideal gas?
Gas equation for?
Real gas equation from ideal gas.
So this gas equation for real gas is written as P plus A over G square into V minus A is equal to RT. So ideally for it was P is equal to RT, but here pressure is written as like this and volume changes to P minus P. This B as value is equal to 4 NX. So this is the equation for real gas.
What is A?
A and B here are constant terms and they have value like A has 27.
So on which factor does it depend, the A and B, and why it is deviating from the ideal gas?
So in the ideal gas, we considered a oversimplified approximation. We consider that there are no interaction between the molecules. Intermolecular attraction is completely neglected in that model. But when we deal with the real situation, real gases, this is not the case actually. Intermolecular forces or intermolecular attractions are there. So because of that, the pressure that we were identifying earlier is not the same, but it is little more because of the molecules when they collide with the walls. So they reflect back from the boundaries. So because of that, pressure terms changes to A upon V square and V changes to like this. So, and these A and B are constants, which these are the temperature dependent parameters. I don't know the exact value. I will do check.
Okay, that's all from my side. Thank you. So we can give feedback.
Okay, Jadim, you can go ahead and give the feedback, then I will proceed.
Okay. So I think you are explaining it properly. So the explanation part is good, but try to listen to questions properly. Okay. Don't just try to answer directly without listening to the questions. Okay. And when you are asked to demonstrate something, don't demonstrate quantum mechanics and all, because I don't think so in Polytechnic they will require this. Yesterday also I told you choose any 12th level or of topics which are which could be utilized. Okay, like EMT, photoelectric effect, interference, young double slit experiment. These things you can explain. Okay, so try to demonstrate these things, because I don't think so they will be using quantum mechanics also, although you must know about these topics. Okay, and that's it for me.
Okay, Vanna. So, okay, I think 2-3 things they would like to know, because you have, I think, what is the basic qualification for that? That was MSc. You could have
BSc,
appeared for, no. So, for example, for appearing the test, what was the basic qualification required? BSc,
MSc NET.
MSc net, right? That was okay. So definitely they are going to check your interest. Why, even after doing a PhD from a reputed institute, why you want to get into over here? Right, and that too in the very, at polytechnic level we have a very basic physics, right? And even if you see in engineering also, if we see the core of physics, particularly the theoretical physics part, that is not that in depth, you can see, even in engineering, because it is mostly in first year and so and if you go to polytechnic, that will be very basic, right? So definitely they would like to know that why, despite having a very good credentials, academic credentials, why you want to get into this polytechnic. Why not get into some engineering college, or maybe in your domain, maybe in other colleges and all that, right? So I think that you need to handle very properly. Overall impression that you need to give is that, okay, you're going to stay over there in that particular domain. So what you can say is that, okay, even though I am specialized in a particular domain, definitely, but just like handling the people or the students who are having a very basic conceptual needs, I think that is going to be quite helpful, because once now I have a exposure of practical as well as theoretical domain, so that I can inculcate in them, right? So I think even though it is basic, but you grow over a period of time. As a teacher, you need to grow, and it takes time. As a student, you may have grown, but as a teacher, you have to grow, and it will take a lot of time. So I think I will be able to do justice. So I will, when I will be teaching, I will be learning so many things that I will, at the same time, I will be contributing a lot of things to them. That way you have to handle it. Little bit diplomatic, little bit something that way, right? Okay, so one question was related to you, whether you will switch over. My question was, if you will get some other good opportunity, so will you go for that or not, right? So over here also you will say that, okay, I will try to contribute to the maximum possible in the domain in which I am over there, and I will try to develop the skills and other areas where I will be able to effectively contribute to this at this particular level. So over a period of time, you also graduate. For example, if I will have, I think that I'm going to have opportunity to prosper in this particular domain, in that particular domain also. So I think that is how I think.
So should I say directly, yes, I'll be looking for higher positions, or
No, you can say that, okay, right now I don't have any option, but once I will get into the domain in which I am right now, if I will get into a post of lecturer, then I think my journey will end, and I will continue to improve myself in that particular area. I will try to gradually kind of upgrade myself, and maybe in hierarchy I may go, so maybe a little faster. That's what I think, if I will contribute in a better way. So try to show, even though they may be knowing that, okay, if you will get a much better chance, so you will be going, but try to tell them that, okay, you don't have any options as such now, but if you'll get, once you get that, then your I think journey will start in that particular direction, right? And I think the part which is related to your thesis, obviously I don't think how much they can ask, but obviously they would like to have, so you have to give a very brief idea what was the problem, what you basically investigated, and what is the scope, right? So I think you have done a good work. That's how is the impression, overall impression. But even if there are some kind of loopholes within, you can just go through that thesis part and try to handle those areas also, right? So overall it is okay, I think. Just a little bit tuning. Okay, Vanna?
Okay, sir.
Any query from your side?
No, sir.
Okay. All the best for your
Thank you,
interview,
sir.
Vandana. Okay,
Thank you,
bye-bye.
sir.